Hi, this is Joel Duff, and today I would like to talk about what some people might call a fossil paradox. They say, look, if you look at any of the individual footprints that any organism makes, what are the chances that they're preserved over the long run in the fossil record for tens of years, hundreds of years, thousands of years, or even millions of years? We'd say extremely unlikely. It seems like that's impossible. And yet we can look at the physical record, the actual observation of the world around us, and see the fossil record contains hundreds of millions of preserved footprints of a variety of organisms, including humans. So how can we resolve this apparent paradox between our intuition that it would be very difficult to preserve any individual footprint and the observation from the physical record, our observations of the world of rocks, where we see hundreds of millions of footprints present? There must be an explanation for this. I want to address this question by looking at a recent paper that examines Neanderthal footprints that were discovered, preserved in stone on the coast of Spain. So to get thinking about footprints in stone, let's first think about the odds, or our intuition that it's very difficult to preserve such footprints. Here's my wife walking down the beach in the Outer Banks, and I'm following her, and she's made a series of footprints. And if you ask, would I expect those footprints to be there 2 weeks from now? You would say, no, absolutely not. Would they be there tomorrow? Possibly, but maybe even tomorrow they wouldn't be. We recognize there's the ephemeral nature of some of the things that we do, namely walking around making imprints on this earth. We've made hundreds of trillions of imprints, each one of us potentially in our lifetimes. And if we were to ask, would I expect any of those imprints to be preserved a year from now, 1,000 years from now, or 10,000 years from now? I expect your answer to be, no, I wouldn't expect that. I wouldn't bet on that, right? I wouldn't place money on that could happen. And yet we know it does happen because we have fossil footprints in the fossil record. Those footprints had to have been preserved. Somebody made those footprints at some point, and somehow they got preserved. So let's see how that might happen. Let's begin by looking at what I'm going to call an alternative explanation for preservation of footprints. That alternative explanation comes from Dr. Andrew Snelling and Answers in Genesis in general, or you could say creation scientists. All right, creation scientists are those who are trying to interpret the evidence of the world within the context of a 6,000-year-old Earth. Everything that we see around us must be explained within a history that only spans that 6,000 years since the point of creation. Therefore, any fossils of footprints that were made must be footprints made by individuals that have lived within 6,000 years, and the preservation of those footprints had to have occurred within that time frame. Now, Andrew Snelling and Answers in Genesis think that they have an explanation for this paradox. In fact, they're the ones that kind of call this a paradox. I'm not sure it really is anything of a paradox, but they like to present this as a paradox or a problem for conventional geology. They like to say, like, look, fossil footprints, well, let me just read this quote here. Biblical geologists, all right, what they're saying, our biblically based understanding of geology, on the other hand, says that it's the conventional geologists who, in fact, face a dilemma, or this paradox. If geological change takes place slowly, surely footprints made in the mud would be obliterated by wind and rain long before the prints were covered by new sediments and hardened into rock. Right? My wife's footprints, how would they get preserved? Right? If geological processes take long periods of time, and so you need a long time for the sediments to accumulate on top of those footprints, well, I mean, the next day, if it rains or if there's any little bit of wind, it's going to obliterate those footprints, and they're not going to have a chance to be preserved. All right, so he then poses the question, how can today's slow and gradual geological processes over millions of years explain the preservation of delicate impressions in mud before they're washed away? Another example he would give is in the fossil record we see fossils of raindrop imprints. where rain has fallen onto a wet surface and created little droplet marks. And we see those preserved in the fossil record. So like, how can that happen if they need to sit there for a long period of time in order to be covered up slowly, all right, by these gradual geological processes? They would be washed away first, right? The next storm would destroy them. The next wind would take them away. Now he poses this as a question, does the flood, and by the flood he means a global, worldwide flood about 4,350 years ago, potentially provide a better explanation? Now he leaves this as a question mark, but of course to his audience he's really trying to say, look, it's impossible for conventional geology to explain the fine preservation of footprints and raindrops and all these things that are very ephemeral and don't last very long. What could possibly explain their preservation instantly? Well, what about a global flood, a cataclysmic event that occurred very, very quickly? And so if something walked over surface then immediately was covered by something else, boom, it would have a chance to be captured in time. Now, I'm going to give you a little clue as to one of the problems that Snelling has here. For one thing, he's setting this up as a false dichotomy. He's saying if, right, and it's a big if here, if geological change takes place slowly, surely footprints made in the mud would be obliterated, right? Conventional geologists don't say that every mechanism or every operation that's happening now happens in very gradual, slow processes. There can be floods, there can be storms, right? There can be tides, there can be things that change the world around us relatively quickly, in which case there's opportunities to preserve very ephemeral things like footprints in the fossil record, and I'm going to show you some examples of those in a moment. Right, so when he says, does the flood provide a better explanation, he's trying to get his audience to say yes. All right, you have two alternatives. Either the global flood explains the geology of the world, or conventional geology that says that the world is hundreds of millions of years old and has gradually morphed and changed over time. And he's saying we have a better explanation for these millions of footprints that are preserved in that fossil record. Now, he says this as a question, but I've gone to Answers in Genesis and other creation scientist seminars, and I have heard speakers who will, make fun of this idea that conventional geologists believe that, oh, if you walked across the sand and then that could be preserved in the fossil record, how ridiculous that conventional geology could explain that. Whereas our global flood model can do that. I don't really think a global flood model helps at all in terms of explaining it, but they try to explain it as a person walks across a new surface, and then immediately in this chaotic environment there's another layer of sediment that's immediately laid on top, and that like freezes those footprints in place. Let's see if that a global flood is really necessary for this. All right, so let's go to our paper from Scientific Reports, Tracking Late Pleistocene Neanderthals on the Iberian Coast. And they talk about a recent discovery of 87 Neanderthal footprints. I don't want to get wrapped up in how do they know they're Neanderthals or not. That's really they can't tell just looking at the footprints that they must be Neanderthals. This is more of the time that they think it happened and other fossil evidence in the area of Neanderthals being present in the area, and so they're connecting those two. For my point that I want to make here, it doesn't matter whether you are skeptical or not, or whether they're Neanderthals. Neanderthal or not, they are some kind of human-like footprints made by a hominid, all right, either a human being, Homo sapiens, or a Neanderthal. And these footprints are found preserved in a sandy, mucky, what was probably an estuary, so a muddy environment that's maybe just slightly inland from a beach, where maybe the tides come in or high tides come in and sometimes get that area moist and wet and then move on out. And so the idea is that people might have, in this case, Neanderthals, and they also think there are several children, so like a family unit, are walking through this area of mud, and then that mud may have dried after they stepped on that mud and made an impression in it. It may have dried enough that the next time that the tide comes in, or a storm or a stream brings in new sedimentation, covers over with a thin layer of sediment on top of those footprints, impressions, and fills the impressions up. And then after that, more and more and more sediment got put on top of that, and so you preserve those footprints in that particular layer. So here's some images from the paper, and so what I want to do is I want to get to, I'm not just interested in talking about, well, how would they preserved, and convincing you that, I guess I will say, normal conventional processes, things that are happening in the world today, have the potential for preserving something as ephemeral as a footprint. But I also want to present you with the challenge that these particular footprints have. And the challenge is to determine, like, when did these people live? And when they lived, then is something that all different models that Christians have for explaining human origins must accommodate. Somehow they must accommodate the fact that there were individuals walking around on a beach or an estuary at some time in the fairly distant past, and you'll see why I'm saying distant past here in just a moment. So here we have a map that shows that this yellow area, orange or yellowish area, mustard area, is active dunes. These are large dunes that are of soft sediments that are blowing and moving around. But this whole region here, many square miles, is inactive dunes, and they're inactive because the sediments are consolidated and they're actually beginning to be cemented together. This is the process of a sand dune becoming sedimentary rock. And it's not completely hard or completely cemented rock yet, but it's on its way. And you can see that in this picture, because here we have the surface that's been eroded by the ocean that's eroding away at these huge sand dune hills. And as it erodes away, you'll see this is the cliff face. And this is not a sand dune, otherwise it would have slumped down. But this is somewhat cemented sand. So it's old sand dunes, right, that are becoming preserved as fossilized sand dunes. They're in that process of becoming fossilized. And where did they find these footprints? This is what makes this particular story, I think, so fascinating. These footprints are found right here, and then right above this particular layer of rock, or highly cemented sand that's harder than the sand above it, these sand dunes above it. Right above it is another thin layer of rock that also contains thousands of footprints of different animals. This particular area has some animals, but it also has what was identified later as human footprints. Somebody who was actually studying the animals here and looking at all the different types of animals that were living at this particular time before several ice ages passed. And so there's a really unique set of fauna there that doesn't exist in Spain today. All of that is found in the evidence just laid out on this surface here. Now, if you go back here, you'll see that this surface would extend underneath, right, what is this massive layer of rock, all right, or soft rock, new sedimentary rock. So that alone tells you that these footprints were not made very recently. They had to be made before this huge layer of sedimentary rock was preserved on top of them. So this is sometime in the past. How long ago in the past? They're suggesting about 100,000 years ago. I'm not going to go through all the dating mechanisms and so forth here. That's not really the purpose of this particular talk. We're just going to talk in relative terms. Oh, so here's when I was saying cemented together, here's an example of a fossilized sand dune. I took this picture near Moab, Utah, and you can very clearly see the layers of sand as the sand was blown around, forming these different dunes. And then as it sat there for a long period of time underneath a whole bunch of other sediment, eventually all those sand particles, the sand grains, got cemented together into this very hard rock, and then it was eroded later, and we see this formation. Speaking to a long series of geological processes occurring. Right now, in the global flood scenario, how would we explain that particular sand dune? I mean, they try to explain them as underwater sand dunes that are made during a chaotic global flood that are then covered with other sediments and then somehow eroded later on. In this case, we have footprints And these footprints are of individuals that no creation scientist would say were made before the flood. All right, we're not capturing people running around trying to escape from global floodwaters. So Noah's preserved on the ark, and these are other individuals that are like running for their lives, because these particular sediments are sitting on top of thousands of feet of additional sediments that have fossils in it. That young Earth creationists say all the layers of rock below these footprints are all formed by the flood itself. So these sediments, or this rock that the footprints are in, are up above the flood layers, all right, the flood rocks, according to young Earth creation scientists. So that means these have to be, in their particular chronology, less than 4,350 years old. And they have to be from the descendants of Noah. In fact, they would have to be from the descendants or from peoples that came from Babel, which is some 400 years, potentially 400 years after the flood. So maybe about 4,000 years old. People would have had to migrate from Babel or the Middle East and move all the way to the coast of Spain, and then trample on this particular surface, walk across this estuarine area. But then later, after they did that, these massive dunes, right, tens of square miles of dunes that are very, very thick, had to develop on top of all them. They had to then solidify, and then you had the ocean coming in and erode. And the idea is that actually these sand dunes probably were all the way out here at one time. And after somebody walked on them, these sand dunes developed in this whole area. This is only like 40 feet deep out here for many, many miles. And then the ocean has been eroding, just like you can see it here. I mean, this is eroded. These footprints were discovered because the ocean eroded more sediment back, or rock back, and then exposed this new layer of rock in which we saw these footprints. And so all this area was covered by all these sand dunes, and they've been eroding back for thousands of years. And this land right here, we know these sand dunes, which are all consolidated, people have lived on those sand dunes for thousands of years themselves. Right? So somehow, somewhere in their chronology between the flood and today, you had to pack all these events. All these events had to occur within that very, very short time frame. Let's look a little more at like the daunting task that a young Earth creationist is faced with in terms of explaining this particular site, explaining the observations that we make of this world. Here is a location that's very close to where those footprints are found. Those footprints are found just down the coast here, but up against this wall. And I show this picture because it shows that this isn't a sand dune anymore. This is layers of sediment that were laid down sometime in the past, including lots of sand. And now they've been eroded. And you can see that they're not hard rock. This isn't like granite or something like this. But this isn't, neither is it sand, right? These particular hills have been here for hundreds and hundreds and hundreds of years, looking approximately like they do now. The erosion rate is not that great. Now, if we go back to the paper and we look at, like, okay, so what's above the footprints? Here's where the footprints are, down here. And then what it's saying is above the footprints, before, what was eroded to now allow us to even see these footprints was this whole entire column of rock, which consists of many different layers of various sediments, all right, with different types of grains. Some has more organic material, some doesn't have as much organic material, representing different climates in the past, representing different types of vegetation that existed. And then there is thick layers of sand. There's a meter or two of sand here, and then covered up by a surface that looks like it was a surface that had organisms or plants growing on it, and then there's another sand dune on top of that. So you get the idea. This isn't just one big sand dune, all right? A huge windstorm came along and piled up 75 to 100 feet of sand on top of these footprints, and then it consolidated and became more like rock. And then it eroded and we see the footprints. No, this is a whole series of events, but that must be separate events to create these separate different layers. And could these have been created by the flood? No, that's the usual explanation the young Earth creationists have. But there's footprints of people underneath them. All right, so this is after the flood, which means all of this geological information or all this series of historical events had to have occurred after those people walked on it, which would be after the flood and after Babel, which means within the last 4,000 years. And then, but we know that people have lived on the top of this surface for thousands of years themselves, which compresses the amount of time to make all these things happen, or to have all these events occur into a very, very short time frame. All right, there's some of the footprints, right? And it's like, this one is probably one of the clearest ones. There are ones that are fairly clear, and this is how they recognized them as being human or Neanderthal footprints there. A lot of the other ones aren't as clear, but once you recognize there's a few of them, you can then trace the other ones that are in the area that have been. And if you're walking in mud, not all your footprints are going to be absolutely clear. Nonetheless, this is thousands of years ago. Individuals walked in a location, and we have their preserved footprints. It happens. It can happen under just the right conditions. So does it happen often? Well, obviously not. But it does happen. So I want to give you some other examples, ones that I've written about in the past. So here's an example I wrote about in 2018. Footprints discovered on the roof of a South African cave. That's a really weird title, right? Footprints found on the roof of a cave rather than on the floor of a cave. And so what do I mean by that? Well, here it is. Here's a small cave along a shoreline in South Africa. So this is the beach. High tide, the water's coming in here, and it has eroded out this area. And somebody was climbing up in here, and they looked up, and what they saw was a series of footprints on the surface, on the top of that. You can go to the blog post and you can see them. And on the top of that was the bottom of somebody's feet. All right, preserved up there, along with a bunch of other animals. And this is actually what the researchers were looking for. They were looking for different animal footprints in these different layers of sediment. This is an ancient sand dune. I showed that picture from Moab of a fossil sand dune. Well, this is a fossil sand dune. These are sand grains, and just the way they're organized tells us that this was a wind-blown sand environment. And that sand then was turned into stone later on. And then when this eroded, we see the footprints. So what do the footprints represent? That represents, well, at one point there was a sand dune that was like right here, about that big. And there was probably probably rained, and so the surface was wet. Somebody climbed up and over the sand dune, leaving their footprints there. Probably dried out during the day. And then a bunch of wind brought some more sand and covered up those footprints. And then more sand came in, and more sand, 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 and so forth. And then some erosion occurred, and then more sand came in from a different direction, and so forth, and built up this massive, actually this is a 150-foot high cliff. And so that 155-foot layers of sand, all right, huge sand dunes. And underneath it all is this evidence that somebody walked by there. And this is all rock now. Now, young Earth creationists in general will point to large sand dunes that are fossilized as being part of the global flood. They'll say under the water you had this turbulence, and you have sand bars underneath the ocean, and you can get a very similar type of layering in underwater sand dunes. The problem is that people aren't walking around underneath the ocean, and also they have found hundreds of other animal footprints here too, of various animals from Africa that are walking across these surfaces. This did not happen underneath the ocean or during a chaotic global flood. This happened while they were sand dunes on the surface. And so this, again, for young Earth creationists, where to put this in their timeline, right? They have a chronology that's 6,000 years old. It couldn't happen before the flood because that was all obliterated. And there's flood deposits below this, below these sand dunes. So it had to happen after the flood, but then how did people get all the way to South Africa, walk across the sand dune, and then have 100-some feet later, and it's already turned to rock, right? There has to be some time for this all to get cemented together into hard rock in this case. These footprints are thought to be a lot older than those Neanderthal ones. Same thing in Crete. There's a layer of rock sticking out near the Mediterranean Sea that has a bunch of human footprints on it. And above that, that was eroded out from what was hundreds of feet of sediment on top of them as well. And lastly, I'll give this example. I think this is very similar, but I think maybe even more striking. Human fossil footprints found below Ice Age deposits. This is in Great Britain and on the shore of the North Sea. What we find is that right down here there was a storm, and that storm eroded some of this wall here. And when it eroded out, there was a layer of rock there, very, very say very soft rock. All right. So again, these are sediments that are on their way to becoming, sandstones and clay stones and so forth. And so they're not soft in the sense they were just made, but they're in the process of becoming cemented. And so here, this surface right here is where a family, all right, a family unit of some type, because they know there's almost for sure kids and adults together here, are meandering around. And what's really cool about this side too is that it looks like the kids are basically all over the place, and the parents look like they're in being more organized. They're probably searching or hunting for food or something like that. And so at one time, below all of this, there was an estuary, all right, where a river is coming down and meeting the ocean, and they're walking along the edge of this river, which is constantly flooding, and they're walking in this muck, all right, in this muddy surface, and they're leaving their footprints there. And then maybe the river overran and brought a bunch of sediment and covered up those footprints, all right? The footprints could dry over a period of a few weeks, and they become kind of hardened in the clay. And then when new sediments are put on top of them, they're preserved, right? As long as more material keeps piling up on top of them, they don't get eroded. So they can be preserved over time. Right? 99.999999999% of the footprints that these individuals and their friends ever made during their entire lifetimes will never be preserved. But if you consider that each one of us and each animal on the face of the earth is making billions of footprints, all right, on the surface of the earth, then all you have to do is say that if 0.0001% of them find just the right conditions and are preserved, we would have millions of footprints preserved in the fossil record just like we see. There is no fossil paradox. Right? There's no fossil paradox if you consider the world being millions of years old. Because if it's millions of years old, there are hundreds of trillions times trillions of opportunities for fossil footprints to be preserved. And it only takes an extremely small percentage of those to be preserved to give us the millions that we see today. So if you think about an individual footprint, you ask, well, what are the chances of it getting preserved? You'd say, well, that's so small, it feels impossible. But when you consider there are so many of them, so many opportunities, it just takes a small chance to preserve a large number of them. All right, back to this particular deposit. So again, this is the same conundrum for a young Earth creationist. Where did these footprints come from? Like, where do you fit them into the young Earth chronology? They're on the surface of sediments that are above thousands of feet of other sediments that they say are part of the flood. So these are fossils, these are footprints made by individuals that must be after the flood, so they're part of Noah's descendants. But here we are all the way up in England. And they had to have gotten there after Babel in their particular timeline, so after 400 years after the flood, so about 4,000 years ago. Somehow they got up here, walked around this river, made these impressions, they got covered up, and then guess what happened? After that, all of this material had to get deposited on top of it, right? Because this surface up here, which goes on for hundreds of square miles, is this thick layer of stuff, which are all considered to be glacial deposits, right? Glaciers that covered Britain, and then larger, higher land above was eroded. As it eroded at the end of the Ice Age, it deposited a ton of material on this particular area, completely burying the river that once was there. And this sediment includes all kinds of other fossils of Ice Age types of organisms. All right, but again, this particular surface has been lived on for thousands of years. I mean, there are very old archaeological remains on the surface up here. And so if you have thousands of years there, and it was only 4,000 years ago that people walked here, how'd that happen? Like, how do you squeeze this all into the chronology? The Neanderthal prints that I mentioned before, I haven't seen any young Earth creationist organization attempt to explain them. But what I have seen is Dr. Snelling has talked about the Happisburg footprints, which are the ones I just showed you. And he asked the question, well, where did these people originate? And here's how he sums it up. So the significance of these human footprints is clear. Just as their human counterparts in Spain, these people were descendants from Noah's family. As I said, they must be from Noah's family, and had migrated from Babel after the flood about 4,000 years ago. One day, this group of people was walking along the river, estuary, sediment flats, and left their footprints in the wet, silty sediments. People still do that today. The next tide had to carry in sediments to immediately cover and preserve the footprints, or otherwise the footprints would have been washed away, the same as what's observed to happen today. These people represent representatives of some of the first humans to arrive in post-flood Britain. Now, what's really interesting about this is that he provides a very natural explanation for how those footprints could be preserved in that rock. And does he have to say the flood did it? Remember the article I mentioned before? He says, well, maybe, could the flood be responsible for this? And many other speakers in Anthrogenesis make it sound like only the flood could preserve millions of footprints in the fossil record. And here, when he's faced with a situation of human footprints that clearly are after the flood, he can't claim the flood is responsible. So then he points to an obvious way in which fossils could be preserved without a dramatic flood event. Now, it did occur with a flood, right? He's saying, well, okay, there could have been the next tide, which you could consider kind of like a flood. It brings in new sediment and covers them up. That's, in my language, that is a process. That's a geological process that's occurring. And so geological processes that are happening right now today can explain the fossils we see in the fossil record, the footprints we see in the fossil record. There's no need to go to a global flood to explain them. In fact, a global flood doesn't provide any better explanation, and I would argue it's a much worse explanation. It's much less likely to preserve footprints. And the fact that there's hundreds of millions of footprints would mean that almost every footprint made somehow by organisms that are trying to escape the flood would all get preserved. Now, it's less likely that all footprints get preserved than 0.00001% of footprints get preserved, which is what conventional geologists are arguing. The paradox is really laid upon the feet of the young Earth creationists to explain, not for conventional geology. All right, just to reiterate that point, I was walking at Death Valley. When I visited Death Valley, I was walking around below sea level, and I found this footprint right here. Right? Somebody had walked in the wet sand, and with a boot very much like mine, had made this impression. And this is very hard. I mean, you're walking around, it feels like you're walking on cement. And so this footprint is well preserved. And I don't know whether that footprint was made 2 weeks ago, the last time it rained, or maybe it was made 6 months ago. I actually followed those footprints, so you can see that one right here. And there's a couple of more footprints that are preserved here. I guess actually there's another one right there. And these footprints go here, and then there's another one right here underneath this sand, and I actually pushed the sand away. And what I found is that it looks like this footprint series goes underneath the sand dune. So maybe these footprints were there last year, last summer, and maybe all this was covered by sand, and maybe the sand has been blown off so now that I can see it. Surely it was made before this sand was there. Right, but this sand might only be a week old. Maybe there was a big windstorm last week and it blew that sand dune over there. So they might only be a week old, but they might be a year old. They might be 5 years old. But what happens if there's a big storm that brings sand, covers this whole area, and then more and more sand is deposited in this area? Eventually these footprints are going to be preserved. And this sand eventually, with enough rain and stuff filtering down through that sand over time, is going to begin to cement together. That could take thousands, maybe tens of thousands or hundreds of thousands of years to become sandstone, and then maybe that would all have to erode again, and somebody will see those footprints suddenly appear again in the future. It can happen. It doesn't happen very often, but it happens. All right, that's the story of fossil footprints in the sand. Again, you can read about these footprints by searching for footprints on my blog, naturalhistorian.com, and I have a number of articles about footprints there. Thank you very much.